the stream. Check, check, got green light.
Are you gonna eat some?
Hola, niños. Oh, I got a green light this time. I got a healthy stream. I think my doctor told me that one time.
You can see
It extra out again.
sparkling. Can I drink that? Don't take it. That's his She's probably from a different class. No, I think it's funny. Salsa, if I can. We're talking like 15 pounds.
Okie dokie, so we're live, Waterfalls. Thank you. So we started partial fraction decomposition yesterday for you guys that weren't here yesterday. So yes, we are decomposing fractions. We're given a rational expression kind of like this, and we want to know is what original fractions they came from. Does that make sense? So that's kind of the objective. That's what we've been doing for those of you that have been gone. The way that we go about that, keep on knocking, but you can't come in. Hold on, did I skip something here? All right, cool. So here's our problem. So here's how we start off the problem. Is what we're going to do is we know that if these were the denominators, there was two fractions, one with each of those denominators, right? And then we don't know what's going to be up top, so we just call those A and B. So this is our setup. We're going to take our rational expression, and we're going to decompose it into two fractions with those denominators. At that point, we're going to go about trying to solve for A and B. The way we do that is we multiply both sides by this denominator so that this cancels out. We're going to get this business once we distribute out on the right-hand side. Any questions so far? Those people that were gone. I know this is kind of fast here, but this is just review. Okay, cool.
Wait, can you go back?
I can. And I'm gonna take it.
Oh, you didn't go to eighth grade, but
If you want, I'll send you some of that. Let me know if anything comes up. Can I change the slide? Did you need that? You need that? You're good? Okay. So once we do that, waterfalls. Thanks for your patience, guys. I'm trying to work with someone. Can't get into a test. But anyways, we were back to here. Once we did, we kind of distributed these bad boys out. We got AX for A from this, BX, negative 3B from here. You want to put your x's together, join them, because then we're going to factor that out. That gives us an idea of the setup for this binomial. We know that the 5 up front has to be equivalent to the A plus B, and that the last term has to be equivalent to the minus 1. We take those pieces, and then we construct a system from those. And there's our two equations. So we construct the system, and then we just solve that system. How you go about solving it is going to be up to you. If you want to use a substitution, elimination, with the matrices, it's all good, okay? So once you do that, that's going to give you a value for B, going to give you a value for A. Take those bad boys, plug them back into our first expression, and you should get your fraction decomposition.
Oh, I didn't put them back in.
Yeah, you should always put them back in, because that's what you're looking for. That's the objective, okay? So let me go on to the next one. So we kind of started this yesterday. I prefaced it by saying, you know what, sometimes if we have some degree of it, we could have a first degree binomial, and then we could just have kind of components of that, right? So let's take a look at how this example would work in this case. Sharisha, you lost.
Very much so.
Okay, guys, if you guys don't mind, I'm gonna go ahead and just start from the beginning for this one. So that who wasn't here yesterday? Show of hands. There was a lot of people there.
Yeah, like, yeah, that. Yeah.
All right, so I don't need you guys getting lost. So here's, yeah, we do have that video, just for the sake of, and this will just reinforce what you're doing here. So if we didn't know this, you could see that there's two fractions that this came from, right? Those two fractions are x minus 3 and something that had a, so those were the denominators, because remember, if you got to get a common denominator, you would take that, and that becomes the denominator. We don't know what's there, so you can call them A, B. The formula that I gave everybody goes A sub 1, A sub 2. Doesn't really matter, just placeholders, okay? So here's what I want to do. I want to create some type of relationship between them. And the way I'm going to go about it is by multiplying, for starters, both sides by the x minus 3, x plus 4. And I'm going to do it on this side as well, to this. So it'll be x plus 3, x minus 3. What am I doing? That would have been bad. X minus 3, x plus 4. What happened? I don't math. Is that okay with you so far? Okay, so here this is just gone, right? We're going to get 5x minus 1 equals, when I distribute those two to this term, the minus 3's will cancel, won't they? That's going to give me a times x plus 4. When I distribute to this term, the x plus 4's will cancel out, and I'm going to get positive b times x minus 3. Right? Let's factor this out. I've got ax plus 4a. Over here I've got bx minus 3b. Simple enough? Okay, let me go over here in the little corner. So here's what I've got. I've got 5x minus 1. I'm going to group these together as ax, bx, and then the other two will just be what? 4a minus 3b, correct? If we look at this green part, they both have x in common, don't they? So we're going to factor out x. But I'm going to write it at the end. So that would be a plus b with x at the end. Right? Nothing fancy? And then these two guys are just kind of stuck together. So that guy is 4a minus 3b. Are we good still? Any questions? Looking at you four here. Okay? So here's what we know. Think about this. You see the x here? You see the x here? That means that this coefficient, because both of these sides are equal, correct? That means that this 5 has to be equal to this coefficient of a plus b. Make sense? Then that means that the second part over here, the constant, has to be equal to negative 1. So negative 1 has to be equal to 4a minus 3b. Right? And then that's the system you solve. Once you solve this system for a and b, then you know what to put here and here. And you're done. It only takes about half an hour.
Perfect. Half an hour to an hour, depending on how
Okay.
it's
And in the video, it goes a lot slower, so you can go back and watch that again. Right now, I'm going to do a different case. This method would be for just linear factors. So I have distinct pieces to it. Okay. Now, this next example is going to be where we have repeated linear factors. So something like this. Okay, this is repeated. So as we get started here, I want to break that down into all possible denominators, okay? Now, that because there's an x here, one of them had to have x, right? At the bottom. One of them had to have x minus 1. But maybe, just maybe, one of them had both of them. Can you see that from here? You can see the x from here, can't you? Can you see this one from there? No, but we know that this is a factor of that, isn't it? And if we were doing fractions, would we have to use the factors, we would just use the greatest common factor, wouldn't we? So this is a possibility. Is there any other possibilities for that fourth spot that you see? No, not really. I mean, the last one was like x times x minus 1, but I think we're good here. I think that would be good enough. And then, of course, we would set this up with x plus 2, x minus 1 squared. What would we put it up there? A, B, and C. Okay? Can I take this out? Yeah? Okay. Just because it's nicer in the bold print. Okay. So here we go. There's our options again. Then we're just going to continue with the same method. We're going to multiply both sides by that the x times x minus 1 quantity squared to both sides. It'll be gone here. And then we're going to distribute 2 over there. Any questions at this point? I just want to make sure that you're processing this. I didn't know I made that sound when I backed up. I didn't think I was that wide. Show me thumbs up if you're good up to this point, or thumbs down if you're not. I want to make sure that no one gets left behind here. And a smile, I love it. All right, cool. So here's what happens. Once we, these would cancel out here, and we're left with the x plus 2 on the left side. When we multiply to here, the x's are going to be gone, right? That would cancel. So you have the a times the x minus 1 quantity squared. When we multiply to the middle part, one of the x minus 1s will go out, so you're going to get the x and one of the x minus 1s. And then when you get to the end, the x minus 1 quantity squared will go out. That's why you only have the x part of it, right?
Yes.
Well, beans. So just want to make sure that we're good. Let me erase this right here. I don't have to come back later on and
Stop. Scaring me.
A kid actually drew me.
Really?
Yeah, he called me a rabbit. I was pretending to carry it. I was like, and then he snapped a picture of me and then he drew it.
That's
And I'm like, oh, that's pretty good too.
No way, I did that.
But I look like the guy from King of the Hill. All right, good? Okay, cool beans. Here's our next step. Then what we want to do is simplify the right side. Here's what it's going to end up looking like. We've got a x minus 1 quantity squared plus b times x minus 1. Well, let's just go ahead and go through the processes here. This is going to get foiled out, if you will. Then we're going to do some combinations. That's the whole extent of it. This is stuff you should have already done, yeah? It does, doesn't it? Ugh, I think I threw up in my mouth a little bit.
You're going too fast.
Thank you, sorry.
He's getting excited.
I know. So all we're doing is expanding everything so that it's just a bunch of terms. So here we FOIL this out. So a times x squared is x squared. A times negative 2x is negative 2ax. A times 1 is a. Then we got bx squared minus bx. And then that's all it really is. It's just expanding the whole thing here.
I'm trying to write it all down.
Yes. Thank you. I'm going to go distract myself real quick here. So that I'm not looking at that.
He's gonna get excited.
I'll tell you.
Okay.
Wouldn't that mean that A?
What?
That mean A?
Not necessarily. Remember, you got to go back and group everything, right?
Well, yeah, I said we
So you have to take these guys together. But you're not wrong. But it's not necessarily A by itself.
You're just racing up.
Because A is going to have some value.
Would you rather eat something with a bug in it and swallow it without knowing there was a bug in it, or eat it and then spit it out after finding a bug in it?
I would just swallow it without knowing because that's a little extra protein.
Yeah. I feel like we do that anyway.
A little, but
I still want to try the chocolate covered ants.
No, chocolate covered cockroaches are good.
You can have that one.
Those are really
You
good.
can have that one. Are you sure you weren't talking to me in crickets?
Oh, crickets are good.
I heard chocolate covered crickets taste like Kit Kats. Waterfalls. Sounds like we're done writing because everyone's conversing now. So here's what we're gonna do at this point. We're gonna write everything in that descending right from the highest degree to the lowest degree. So we're gonna go. Here's our so ax squared and bx becomes a plus bx squared plus these are the ones that had an x in front of them, just an x, and then finally the constant at the end, which is just an a. And here's what we're gonna do with that bad boy. We know that because of this, a plus b has to be equal to. How do we know that? Is there an x squared quantity up here? No. So that would be a. Oh, that would be a 0. And then what's x going to be equal to? All of this right here.
Wait, can you explain that one more time? How that's gonna equal 0?
So see how this has an x squared?
Yeah.
If I were to add an x squared, can I do that?
Yeah.
No, I can't because that represents one x squared, doesn't it? But if I add 0 x squares, I haven't changed the problem, have I? Right? So now I can say, oh, whatever's in front of x squared has to equal 0. And whatever's in front of x, aka 1, has to equal the middle part. And then what's a going to equal? 2.
Wait, I see. Yeah,
Okay. Which part?
the whole thing.
What?
This whole slide.
Okay, here. Let me go back. Are you okay up to here? Okay, cool. On our right side, we have an x squared value, don't we? Is there one on the left side to match up to? There isn't one, so I'm going to add one. But I can't just add it like this because that really represents 1 x squared, doesn't it? So I'm going to put 0 x squares in there. So here's what I'm going to do.
A plus b equals 0.
Yes. So whatever's in front of waterfalls. So whatever's in front of x squared will equal whatever. What did I do?
No idea, but it said 0x squared.
It did, didn't it? So whatever's in front of x squared on the right side should equal whatever's in front of x squared on the left side. Then if I go over to x, what's in front of x? Negative 2a minus b plus c should equal whatever's in front of x on the left side, which happens to be a 1. And then finally, my constant a should equal whatever my constant is over here, which is
Oh, they're equal to each other.
right. Those segmented parts are equal to each other. So that's not too bad because here's what I know.
Oh my God. I see that.
If a is 2, then what is b?
-2.
Negative 2. Then I can just take those, plug them into this middle one, and find out what c is equal to. Okay?
Do that.
Yeah, pretty sweet, huh?
Do it. Cute.
You mean find them?
Please.
Well, we know what a is. A is 2, right? So if a is 2, then b is a negative 2 because it has to equal 0. So here is, this is going to be 4 plus 2. Thank you. And this is positive 2, right? And then that's going to give me c, that equals 1. So this is going to end up being negative 2. So add 2, so c is 3. And there it is.
So you don't
That
have
is
to-
really cool.
Wait, so you don't have to do systems for this?
Not in this case, because that's pretty much done. Once you have one,
You have to do a system.
not always. Sometimes you will. There'll actually be some where you have to have your 3x3 system. But then what are we going to do with 3x3 system?
Plug the zeros in.
Plug it into a calculator. Let the matrix RREF do it, right?
Wait,
Reverse world X.
Yes, I can. I don't want to wait.
So how do you put it in like the
He has to
fraction
be in
form?
his third hour.
You should already have from the beginning, right? We had x, and then we had an x minus 1, and then we had an x minus 1 squared, and then you're going to go a, b, c.
Oh, okay.
I'm confused how to get C3, but then
How to get c?
Oh, I think that was your nails, bro.
What was a? Plug it in here. So what's 2 times negative 2? 4. And then we put a in here as well. So if we have 2 plus b equals 0, there it is. So we plug in a negative 2 in here. Negative makes positive. So there's that. Plus equals 1. It's just algebra. It's just algebra. Algebra. Who's still writing? I smell lemons. Who's squeezing lemons in here? You serious? You're squeezing lemons? You smell like lemons?
We're talking about stuff.
Is that you? Okay.
He eats lemons and apples.
I love that lemons and apples.
Yeah. What is that?
no, like lemon juice on apple juice.
Okay, no.
It's good.
Because I've never tried it.
It's really good.
You want to know what someone told me? This was almost 4 years ago now. And I think I might have told you. Peanut butter and pickle sandwich? No. Do you know who tried it?
I can't try it.
I tried it.
I wouldn't be able to try it.
Why?
I'm allergic to peanuts.
You're allergic to what? Cheetos? Yeah, I can have peanut butters and peanut butter pickles without allergic to Cheetos. Waterfalls. I will say this about peanut butter pickles. It's not, but it's not like, it's just kind of like, it's just meh. Yeah, I thought I was going to get like some kind of like strong feeling one way or the other. See, what? No, what?
When I was in second grade, my art teacher told me she liked her sandwiches.
Waterfalls.
Peanut butter, mayonnaise, and bananas, and that just stuck with me ever since.
Ooh. Did you see what we're doing now? Oh, I thought you were talking about ooh on that. So we got partial fraction decomposition. We did linear factors. We did repeated linear factors. Now we're going to do quadratic factors.
Oh my god.
Back again.
Wait, can't we just democracy? I know factors.
No, that's not what we're going to do. You know what? Let me get back to you. That's not a bad idea. You know what? That's an interesting question. I like that. Okay, so here's what you need to know. Whenever we had the linear factors, thank you. When we had linear factors, the numerator was 1 degree less, right? So there were constants, aka x to the 0 degree. When you have a quadratic, then the numerator will be some term that is 1 degree less than that. What's up?
So, you know how you said a denominator could be the x times x minus 1? If you did that, would it still come out to the same answer?
But you'd probably get a 0 as a numerator, which would turn out to just drop itself out.
Oh, okay.
And that's what happens. Like when one piece does not belong, then the numerator becomes a 0, and if you have 0 of something, then it's not even there. So yeah, pretty cool, huh? All right, so now here's what you need to know about quadratics. If you have a quadratic factor, then the top will become a linear equation. So instead of doing A, B, C, if you have a quadratic, you got to make sure that you put it in the form of a linear factor. So it'd be ax plus b or bx plus c, depending. So here's what I mean. So in this case, this would still break up into x plus 3. That's a linear factor, correct? So up top, something to the x0 degree, which is a constant, plus, here's my quadratic. My top has to be a linear factor, so a, b, x plus c. And that's our setup. It's not a big deal, is it? Because then it just works just like the last ones. We're going to multiply both sides by that denominator, figure out what's on the right side, simplify it, factor out, set up some systems if we need to, and then we're good to go. She's like, nah.
Wait, should I go open it?
Oh, every time when I was actually looking at the lights, and they were saying,
I go and open it.
because when they stopped, they kept on going, and they were like,
Waterfalls. Let me clear this up. Now that we've seen this, I'm going to just kind of, because I want to get to the other one as well. So there's our setup, just like I said. You've got your linear factor, you have your quadratic. You've got your linear factor, you've got your quadratic, you've got your constant, and you've got your linear factor right above that, Raul. So here's your setup. We're still doing the same old thing. Get rid of that denominator, multiply both sides by it. Now, here they kind of took a shortcut. Instead of doing it on both sides, they kind of took the whole thing and multiplied it by this. Because you'd have to multiply here, multiply there, multiply there. So, Reese, it's the same thing, just looks a little bit different. And they're getting pretty crazy, but it's still the same idea, yeah? Yeah, Guten Tag? Okay, what's going to happen here? These are going to cancel. We're going to end up with this piece.
air quotes.
Here, let's just do that, air quotes. Oh, yes, thank you. They're going to cancel air quotes. So this will give us ax squared plus 12x minus 20. When we multiply to this term, we're going to get a times what? Yeah, the quadratic piece, x squared plus x plus 2. And then we multiply to this piece, you're going to end up with bx plus c times x plus 3. Right? Do you see it?
No.
Do you see what I see? No?
I don't know.
No, Evan? If we multiply
Those all cancel out.
this to this, the x plus 3 will hit that out. So you're going to end up with a times this.
And the other one, the X plus.
This cancels out, and you get the numerator times the denominator. Good? Jamie, you just reminded me of, I went to a conference one time, and, well, I've gone to many conferences, but one stands out the most in my mind.
Yeah.
When you go to conferences, teachers are iPad and iDevice type of people. They're everywhere. Like, I'm not. I've never been. So I always been Android. But it's funny because there was something on the board that people wanted to get. And you could, and I stayed behind because I have a good Zoom. I had an Android. But you could see everybody had.
Are you sure it wasn't pixelated and blurry?
No, mine was pretty damn good. But anyways, you could see this crowd of teachers holding up their devices like this, trying to reach like you were. Looked like some kind of yoga move. iPad to the sun. It was great. But you see all these iPhones and iPads and people are just kind of doing this. Waterfalls. So I'm going to get rid of this. We're going to move on. I'm so glad you guys made me try that again. The circular race. Because I had done it with an old version and it never worked. So I quit trying.
Not them, it was me.
Well, you did. Yeah, like I quit trying because like with older versions it wouldn't do it ever. So
I always saw you, you're like,
yeah. So there's that bad boy.
Anything we learned from Mr. Rozzo, how to erase on smartphones.
Alright, let's carry on. So we're trying to simplify the right side. Here's what we have. I'm gonna wait. I'm gonna wait.
I'll wait. Okay, Foster. I'll wait.
We're not making fun of other teachers, we promise.
Wait. Hold on. Yeah, we do.
Don't be bullying Haley right now. I need you to focus on this. This is the next piece right here. So we're gonna clean this side up. Of course, we're gonna distribute, right? This would be give us ax squared, ax, 2a. That just foil here. So bx squared, all that jazz. Oh.
Oh my gosh.
Stop.
That's disgusting.
It is, but at the end you're cheering. Yeah, I got it.
Oh my gosh.
What do we want to do at this point? We're going to reorganize so that stuff is from the highest degree to the lowest degree, right? Because then we can start separating stuff out.
Wait,
So
go back.
go back to, it's here again.
Stop. He's getting excited.
I'm not, maybe I am.
I'm getting hysterical. So we just distributed the A's so that
That's all we did.
boiled that. Do you remember how you told us the story of how
Yeah, thank you, I appreciate it.
how a teacher emailed you like about the Oxford comma or whatever?
Oh,
Was it Miss Fitzgibbon?
no.
Oh, Miss Fitzgibbon, that's something she did to me. She's like grammar. I'm like, I read it through 3 different grammar programs. What grammar? Grammar transition. I would transition are. No, it's not what you
Waterfalls. So let's just take this again. Here it is. And then we're going to put them in order from the highest degree to the lowest degree. Once we do that, we're going to get this jazz. A plus b, x squared. A plus 3b plus c, x. And then our constant. Right? So what does a plus b equal? 8. What does a plus 3b plus c equal?
12.
What does this make? There they are. Now we have another system
Wait, how did we get negative 20?
from right here.
Yeah, but how?
That was there.
Yeah, but like that one's not a constant, that one has numbers, and then we made it a what?
What?
I see the negative 20. How do we turn the negative 20 into the 2a plus 3c?
From here?
I see that it's right there, but how?
Okay, hold on. It's okay, it's okay, it's okay. I think I know what he's saying.
Yeah, I got that.
These guys go here,
I got that.
right? And then this guy, and this guy, and this guy go right here.
I got that.
And then 2a plus 3c go right there.
Yeah, it's great and all, but how does 2a plus 3c equal negative 20?
Okay, oh!
Got that. Yep. Yeah.
That means, does this have any x's in them? Right? There's no x's there. A and C are just numbers, so once I clean this up, it'll give me a single digit, aka negative 20. Yes, that was me. I answered your question.
I got it now. Can I get a picture? From now on, I think
Please don't. I've invested too much time in that one. Thank you for being so kind, Cherise. Oh, we changed it now?
No, it's just whatever.
What is it? Shara. Oh, Shara. Shara. Falls.
We didn't have mirrors in our 8th grade girls' bathrooms until we left, and then they put mirrors.
So here's your system. You got 3 equations. You're going to want to go and obviously solve those however you want. Here's your results for all of them.
Wait, we got systems?
What?
Go back.
Go back to what?
No, wait.
Right here. The system is right here, sir.
Oh.
Right here. It's just those 3 equations.
Wait, so how would we?
How would you solve it?
Do 2 and then 2.
Matrices.
Remember we showed us?
Here's the way that I would do it.
Well, why wasn't he here? So can you indulge me?
Move on.
I would slap the living. You did good.
Waterfalls. Well, I want to take notes on this guy. I'm going to show you how to do it on the calculator so you can be fast and efficient. Come on, calculator. You're not being fast and efficient. Oh, there you are. Okay. Waterfalls.
What did you guys use?
You need to follow.
It's gonna be a 3x3, right?
No, this is not a 3x3. I went to second matrix. That puts me here in the menu. Now, just write the notes. Please don't follow the calculator, because then that way you can check if your notes work. Okay? Second matrix. I'm going to go over to edit. At this point, I can tell it the dimensions. This is 3 equations, so it has to have. Oh, sorry about that. So it should be a 3x4. Now, for the first one, where was it? On the first one, we have no C part, right? So this is going to be 1, 1, 0, 8. So we're going to do
1,
1.
1, 0, 8.
Oh,
That's really good.
on the next one, what are my
1, 3, 1, 12.
1, 3, 1, 12? 1, 3, 1, 12. Last one?
2, 0, 3. -20.
Cool. So there's my system. Okay? I'm going to quit. And then I'm going to go back into the matrix because I want to do some matrix math. So I'm going to go to the math on the matrix and I want to do function B, RREF. So I'm going to go up to B. And then which matrix was it? Well, I can find inside the matrix names, which is the first one. Push enter. That means that A is 2, B is 6, and C is -8. It was good meeting you too. Tell Jojo I said what? Please do your exit tickets. jmunoz.me/exit.
I'm just a coach, Steve.